right, today's lesson we're going to look at how to find the distance between a point and a line, and we want to find that shortest distance between there. So in this example, we want to know how far is it from the point -3, 2, and we could graph that point out. -3, 2 is right there, and the line y equals -x plus 7. Well, we know how to graph that line. It has a y-intercept at 7 here. 1, 2, 3. Oop, up one more, and then the slope is -1, so we want to go down 1, right 1, down 1, right 1. So what is the shortest distance between that line and the point we have? So we're trying to figure out what is that distance there. Okay, so how you do that is to find the shortest distance. If we want to find the slope of the line that we have, that we're given, find the perpendicular slope to that, because as it turns out, the shortest distance between a point and a line is perpendicular to the line. So we want to be able to find that perpendicular slope. Then we're going to find the equation of the line using the perpendicular slope and the point. Find the intersection of those two lines, which you've done before, and then find that distance. And we'll kind of refresh you on ways you can do that. So let's go back through this problem and find those things. Same problem we looked at to start with. What is the slope of the line? Well, we know from here already that the slope is -1. Now, what's the perpendicular slope? Remember, perpendicular slope, you want to take the opposite sign. So this one's negative, so the other one's going to be positive. And then you want to find the reciprocal. Well, if this one has a slope of -1/1, if you flip that fraction, it's still 1/1 or 1. So the perpendicular slope is +1. Now we're going to find the equation to the perpendicular line. We can do that with our point slope equation here. Y minus y1 equals m times x minus x1. Okay, so putting in the perpendicular slope, we got 1. We want to put our point from up here. So x minus -3. And y minus 2, and then we're going to simplify that down. So if we distribute the 1, it's still going to be x minus a negative, same as adding. Add 2 to the other side, and we get y equals x plus 5. Okay, next part, D. We're going to now find the intersection of those two lines. So what's the intersection of the line we started with and the line we have now? Well, those two lines, y equals x plus 5, and the line we began with, y equals -x plus 7. We could solve this with elimination would be one way. Our x's here would eliminate. So if we add the left side, we get 2y. If we add the right side, 5 plus 7 is 12. Divide, and we find out that y is going to be 6 where those intersect. We need the associated x coordinate. So now we want to plug that back in. I'm going to plug it back into this top one here. So if y is 6 and we got x plus 5, looks like the x that goes with that would be 1. And so the intersection point of these two lines is the point 1, 6. Now we want to find what's the distance between the 2 points. The point we just had, 1, 6, and the point we began with, which was -3, 2. What's the distance between those? Well, we know how to find distance between 2 points. You've been doing it since geometry. If we want to find what's the distance between this point and this point, think about the associated right triangle that would go with that, and we got a great way of doing that with our good old a squared plus b squared equals c squared equation. So we just want to find what's the length of those two sides of the right triangle. Count the spaces. We got 4 spaces here. Go up. We also got 4 spaces there. So we got 4 squared plus 4 squared equals c squared. That's 16 plus 16 equals c squared. That's 32. Last step, take the square root, and we got square root of 32. That's the shortest distance between the point and the line. Now, if this is ACT, they're probably going to do some simplifying of that for their multiple choice answers, and we know how to simplify. I think there's a perfect square of 16 we could pull out of this. And so simplifying that, the shortest distance between this would be 4 square roots of 2. So the shortest distance here between the point and the line is 4 square roots of 2 long. Another way you can also do that, that you did in geometry and that we'll review, is distance formula. Distance formula is related to Pythagorean theorem, and what you do is you subtract your x values. That gives you that length across the bottom of the right triangle, plus the difference of your y's from your points. That gives you the height of that right triangle. Square them like you do in Pythagorean theorem and take the square root, and you get the same thing. So if you did it with distance formula, you should see a lot of the same stuff we just got from Pythagorean theorem, because that's where distance formula comes from. Our x's here would be those 2 points. So if you subtract those, -3 minus 1 squared, that's -4 squared, which is 16, same number we had before. If we subtract the y's, that's our second 2 points here. We got 2 minus 6, which is -4 squared, which is also 16, just like we had before. Remember, we're taking square root of all this, so we get square root of 32, and that's the same answer we got before. That simplifies down to this. That's the shortest distance between the point and the line. Okay, so that's the process you go through to find the distance between point and line. Let's try another one here. Find the distance between this point and this line. Okay, first thing again, we want slope. Now here, a little harder to find the slope if we're not slope intercept, so let's change this to slope intercept by adding the 2x over. Okay, so we know the slope of this line is 2 from here. Okay, what's the perpendicular slope? Perpendicular slope would be opposite sign, so that one's positive, this one's got to be negative, and we want to do the reciprocal. We can do that by putting this over 1, so the reciprocal would be -1/2 here. So that's our perpendicular slope. Now, what's the equation of the perpendicular line? Start with your point slope again. We got y minus 4. Our slope's -1/2. Our x value here is -2. Simplify this out. Minus a negative is going to turn into plus here. Then we want to distribute. So we get -1/2 x. -1/2 times +2 is going to be -1. Add 4 to the other side, and we get 3. So now next thing we want to do, find the intersection of our 2 lines. 2 lines being this one and this one. So we got y equals -1/2 x plus 3. Y equals 2x minus 7. This one doesn't work as well with elimination. We could probably do some multiplying here, but we could also really easily do this with substitution. Y equals this, so let's just substitute that in for y there, and we can get an equation that we should be able to solve. So now we got 2x minus 7 equals -1/2 x plus 3. One way you could do this, if you have fractions, is you could multiply through everything by 2 here and, to get rid of that. So if we times both sides by 2, that would get rid of our fraction. So now we'd have 4x minus 14 equals -1x plus 6. Add this over, you got 5x equals, add the 14 over, we got 20, and divide by 5, and we get 4. So that's the x coordinate. We also need the y coordinate though, so then we want to plug that back into one of them. I'm going to plug it back into, like, let's go this top one here. So, or the bottom one, y equals 2 times 4 minus 7, that'd be 8 minus 7, or 1. So the x or the y coordinate is 1. So now find the distance between the point we just got for 1 and the point we started with, which was -2,4. Okay, so we can do that with distance formula, or you can kind of think, what's the what's the distance between here and here? Going from -2 to 4, that would be a distance of 6. You could also do the same with your y's. What's the distance from 1 to 4? That would be a distance of 3. And so on the right triangle, it would look like this on the picture where the distance across the bottom was that. You can do Pythagorean theorem and find that. 6 squared plus 3 squared equals c squared. That is 36 plus 9. That's 45. Take the square root of both sides and you get 45, and then simplifying that down, there is a perfect square in there of 9, and so the simplified answer would be 3 squared, so 5. That's the shortest distance between the point and the line. Okay, another one here. Find the distance between this point and the line. This one's already in slope-intercept form, which is nice because we know now our slope is -2. Our perpendicular slope would be opposite reciprocal. Opposite means this one's going to be positive. Reciprocal of 2 would be 1/2. Positive 1/2. Find the equation of the perpendicular line now. Okay, so start with our point slope here. We got our y point. Our slope is 1/2. Our x is 6. Okay, so we minus the negative is going to turn into +8. Distribute. Okay, -8 over, and we get 1/2 x minus 11. Okay, now find the point of intersection. That's where we want to solve this system of equations now. So we got this equation here, this equation here. We want to solve that. And y equals half x minus 11. This one looks like another one. Do some substitution here. We can solve that. So basically set these two equal to each other. So we got half x minus 11 equals -2x minus 4. I'm going to use that trick again of getting rid of our fractions by multiplying through. So let's times both sides by 2 to clear out the fraction. So half of 2, that's now 1x minus 2 times 11 is 22 equals, now here we got to multiply both these by 2 because we multiplied on the other side. I'm going to add 4 to x to the other side, so now that's 5x. I'm going to add 22 to -8. That's going to be 14. And so it looks like x here, if we divide, is 14/5. Or that's also about, I think 2.8, or it is 2.8. Okay, so that's our x value. Now we got to find the y value, so plug that back in. Either one's fine. I'll do the top one here. If you plug it into the top, we're going to get y equals -2 times 2.8 minus 4. You can go on the calculator and do that one out. It's going to come out to be -9.6. So our point here is 2.8 and -9.6. Now find the distance between those 2 points. So what's the distance between this point and the one we started, which was 6, -8. I'm going to go distance formula in this one just because of the numbers. So subtract your x's here. So 6 minus 2.8 squared plus, and do the same thing with the y's, -8 minus -9.6 squared. Subtracting these, we're going to get, looks like 3.2 squared. Here we got minus and negative, that's going to turn into plus. So that's 1.6 squared. Got to carry the square root through. Okay, so now squaring those, 3.2 squared is going to be, let's use calculator to do that quick here. So we have, there we go, 3.2 squared gives us 10.24, and then we also want to do 1.6 squared is that. Add these two numbers together, because that's what we do in distance formula. And so we get 12.8. So now what we got is this is going to come together to be square root of 12.8. And now we want to see what that is. Now, I don't think this is going to be a nice one. Um, so what we can do here to figure out that exact answer, what you'd see on ACT, let's convert that to a fraction. So remember on your calculator, if you hit math, fraction, this should convert that into a fraction for you. So this is the same as square root of 64 over 5. Now let's simplify that. So we know from simplifying fractions that's the same as square root of 64 over square root of 5, which would be 8 over the square root of 5. That might possibly be your answer. ACT, though, oftentimes rationalizes the denominator if it's a radical, so we can rationalize by multiplying by the same square root over the same square root. And so we would get 8 square roots of 5 over 5, which is probably how they would have the answer on the ACT. That's the shortest distance exact answer that they would have. All right, I want you to try one, see if you can find the shortest distance between this point and line. Okay, let's see what you got. Trying this one out. The slope of our original line here is -1. Perpendicular slope then would be +1. If you find the equation of that line with point slope form, it comes out to be this. Now we want to find what's the intersection between this line and this line. So solving those two out here. You could do elimination, would work pretty well on this one. The x's cancel, so y plus y is 2y. 2 plus 10 here would give us 12. Solving that, you get 6. Plugging it back in for y here and solving that gives you 4. So we know that the intersection of those 2 points would be 4, 6. Now putting those 2 points and finding the distance between them with distance formula or Pythagorean theorem should get square root of 2. So, and that one can't be simplified, so that would be the shortest distance between the point and the line. All right, you try some of those out now on the worksheet that you got.